Welcome back. The objective of this video is to look at a more complicated deferred annuity question, and we also want to calculate the future value at year 10, and also we're going to do what we call an equivalent annuity between year 1 to 4. And what an equivalent annuity is simply we want to redistribute this cash flow as shown here. So between 3 to 6 we're going to have $20 per year, and 7 to 9 we're going to have $10. We're going to redistribute this so that we're going to have an amount between year 1 to 4 such that it will be exactly the same as this cash flow as we had drawn here. Okay, so let's get started on the present value. Okay, so in order to do the present value we need to discount everything back to time 0. So the first thing we should notice that this is actually just two annuity. There's one annuity here and there's another annuity here. So we're just going to apply the deferred annuity method, and we're going to get the present value by adding the two annuities together. So let's get started on that. So on the left we have the annuity with the full $20. Okay, so we're going to calculate the present value at times 2. Okay, why is it time 2? Because we're calculating present values of annuity. We always find it one period before the first annuity payment. So since the first annuity payment is year 3, we will find the present value at year 2. And here I have just quickly used the interest rate table, worked out the factor, and got an answer for present value to be at year 2 to be $63.39.8. Okay, similarly we do the exact same thing for the second annuity, which is 3 lots of 10 that starts at year 7. So once again we find the present value of this annuity at year 6, one period before the first annuity payment, and we simply use the interest rate table again, get our factor, and we work out the present value at times 6 to be $24.87. Okay, so that's the first thing we do. We essentially sum up both the annuity into one single cash flow at a particular time. Okay, so the second thing we do now is we redraw another cash flow diagram with just the single payment to make our job easier. So we can rewrite the previous example with a single cash flow at year 2 and another single cash flow at year 6. And all we want to do now is discount each of them back to time 0. Okay, so here I just use the formula. So for people that are either using the equation or using the interest rate table, I just kind of use a bit of both so that you can kind of follow along whichever method that you use. Okay, so here we know the present value at time 2 is $63.39.8, and the present value at year 6 is $24.87. So here these two are now future value respect to time 0. So all we do is just discount each of them by the time period to get the present value at time 0. So the present value at 2 was $63.39.8. We divide that by 1.1 squared because it's 2 period, and we divide the 24.87 by 1.1 to the 6 because that's 6 period from time 0. And once we do that, we just add them both together, and we get that the present value is $66.43. Okay, so this is how we find the present value of the annuity that we have shown in the example. So this is how we calculate the present value at time 0. So the second part of the question asks us to find the future value at year 10. So we want to find the future value at this point. So what we're going to do now, I'm going to go through this two ways, a very simple way and a more complicated way. Okay, and I would suggest you to just use a simple way if you understand the concept. Okay, so all we have to do to work out the future value at time 10 is to simply go, alright, this set of annuity must have the same value no matter where we go. So if we have the value at time 0, all we have to do is find the future value at year 10. So we can just simply use the equation f equal p bracket 1 plus r to the t, because we know r is 0.1, we know t is 10, and we simply apply the equation and we get that the future value at year 10 is 172.31. Okay, so this is how we would do it if you understand the theory relatively well. Okay, however, we can also go from the beginning. Okay, so here I redid the question, working out future values, if you don't understand the previous idea. So what we do is exact same thing as before. We find the future value of these two annuity firstly. Okay, so we want to find the future value of the 420s. So here we have finding f given a of I and n. We know that I is 10%, we know n is 4, so we can work out our factor. So we can find that the future value is $92.82. So remember, this is at the last annuity payment. So for future value, is always at the last annuity payment. Okay, similarly, we do the same thing for the 310s. Okay, and we work out the future value at year 9 to be $33.10. Okay, so then what we do is we just do a new cash flow diagram like we did with the present value case, which showed just the sum of annuity value at year 6 and 9, and what we want to do now is compound it to the future value at year 10. Alright, so now we just apply the future formula, the future interest formula, to work out the future value. So in respect to the future value at 10, future value 6 and future value 9 are technically like present value, so we kind of gonna discount them forward. Okay, so we use the compounding equation, p times 1 plus r to the t. Okay, so all we have to do now is go the future value at year 6, which was $92.82, times it by 1.1 to the 4, because between 6 and 10 there are 4 periods. Okay, plus the future value at 9, which is 33.1 times 1.1 to the 1, because there's only 1 period. Okay, then we just simply add them up and we get the exact same answer of $172.31. So the last part of what we're doing is we want to find an equivalent annuity between year 1 to 4, which represent the initial question, which was this. Okay, so this is what we want to show. We want to represent this so that we can do it in 4 payment. Okay, so this is now a relatively simple question, because we know the present value at time 0 to be $66.43. So all we have to use is go to our interest rate table, look at that column that says find a given I. We know the interest to be 10%. We know the period of annuity to be 4. So all we do is just get the present value and times it by the factor, which is 0.3155, and we get that for an annuity of 4 equal period to be $20.96. Okay, so the initial deferred annuity, the deferred annuity series, we have now represented using 4 $20.96 payment in the first 4 years. Okay, so one thing you notice is as you go further on in time, the value of money decreases. So the earlier you have the annuity, the more it is worth now. This is due to the fact that we discount our money as we get further on in time. Okay, thank you.